Okay, I'll give a short summary of whispering gallery mode silica resonators for biosensing on communications. It has been done for the project. And the basics of whispering gallery mode resonators is a curved surface that guides a laser light around due to total internal reflection. And we chose the most simple geometry, the sphere, because it's relatively simple to fabricate. Other geometries have other advantages that can be used for different applications also. And the fabrication method is semi-automated, that we have a motorized stage that moves this fiber towards a hydrogen flame, and a little ball of silica melts on the tip. This automation allows us to replicate to a certain degree these resonators and make a relatively good Q factors for them. There are several sensing mechanisms that can be used for sensor applications using whispering gallery mode resonators. The most common one is the resonance shift, because the resonance frequency depends on both the size, for example, the radius of the resonator, and optical refraction index, which can change due to outside influence. For example, here's a picture of temperature, how the temperature is raised for 5 degrees, and the resonance shifts constantly, linearly to the side. And second thing that can be also used is the resonance broadening. This happens when we have like particles which attach to the surface, and we use this for biosensing applications. When we add additional materials to the surface, the resonance broadens, but it's still possible to observe some kind of shift afterwards. Of course, if the resonance is too broad, then the resonator is not good enough, and no application will be possible. So we have to choose carefully these materials we coat on the surface. Here's one example when here's 2 things coated on the micro resonator. It's gold nanoparticles, which are known to increased sensitivity, and the second one is glucose oxidase, an enzyme which is sensitive to glucose. So this gives us the selectivity needed for biosensing. And we performed different measurements with different combinations of these coatings, and when we use both the glucose oxidase and nanoparticles, we get the better sensitivity for glucose. We have also published last year publication about this. If you're interested, you can check it out further. Another similar approach is using zinc oxide and antigen antibody reactions for sensing. Zinc oxide is used as a surface for other molecules to attach, because these antigens did not attach without zinc oxide present before. And we also got some measurements when we could detect something happening when there was a probe with an antibody present. So this is potential for further measurements, because we stopped due to time constraints as our project ran out. And the second application is in telecommunications, which we are doing currently. The idea is that there is nonlinear effects present in the resonator, and as they have a very high Q factor, the power inside the resonator gets amplified quite a bit. And therefore, we can observe frequency cones. It's like we have a single pump frequency, and after circulating inside the resonator, we get several side bands, which are very equidistant. And the application is using for VDM data transmission. So instead of a laser, multiple lasers, each having their own like noise and drifting in time, we have only a single pump, which eliminates this unknown factor of different lasers. And as we have observed, the stability of such a combine, the frequency stays in place very well. And also if other outside factors like temperature influences are minimized, then the long-term stability is also acceptable. And we have demonstrated also some data transmission and also have application about it. So our resonators were good enough to send data for telecommunications. Okay, this is like short version of these two applications that whispering gallery mode sensor, whispering gallery mode microspheres are suitable for. Okay, have any questions?
Thank you, Inga. Please, some questions to the speaker.
Yeah, I have a question. Can you hear me?
Yes.
Yeah. What is, when you produce these microspheres, what is the size range that you can produce?
Depending on the technology, if we just use 125 micrometer fiber, we can produce from about 250 to 700 micrometer spheres. If we taper it first, we can produce them much smaller, like 120, something like that. So.
Thank you.
Thank you. We have time for one more question. Oh, I don't see any.